everyone, this is Mrs. Snowbeck. Today we are going to do Unit 4, Lesson 3, and it is all about rectangles. So let's start with the definition of a rectangle. You guys know what rectangles are. You've been studying them probably since preschool. But a rectangle is a parallelogram with 4 right angles. A parallelogram with 4 right angles. And remember, a right angle is a 90-degree angle. So a parallelogram is gonna, a rectangle is gonna look kind of like this. That's a rectangle. It's got all the properties that a parallelogram has, plus it has the 4 right angles. So let's list the properties. The first one, the most important, is 4 right or 90-degree angles. That's what makes it a rectangle. The second is the diagonals. Diagonals are congruent. So let's talk about that one. In a rectangle, if I go from one corner to the opposite corner, that's a diagonal. And then if I do the other diagonal, those will be the same length in a rectangle. Here's kind of a cool story. So I was at the cabin going on a walk, and a few cabins down there was this elderly man. He's 84, and his name was Marlin, and he was putting up some 2x4s, getting ready to pour cement on the ground for a new garage floor. He was going to build a garage at his cabin. So he was putting the 2x4s, you know, and kind of propping them up in the ground, staking them so that the cement truck could come out and pour the cement inside. And he's like, Jen, come over. And what he did is he had me stand on one corner, I'll be this green dot, and he stood across from me, and we took a string and we put the string from one of us to the other. And he put his finger there where the string ended at his corner. And then he moved up here and I moved down here, and we took the string and we were checking, is it the same length on the opposite diagonal? And it was about 2 inches short. So what he knew is his corners were not square because the 2 diagonals were not exactly the same length. So he had to adjust his boards so that his corners would be square, so that when he built his garage, it would be nice and square. Okay, I know that was a long story. Moving on. So step number 3, or property number 3, is opposite sides. Opposite sides are parallel, and we're just going to use the symbol, and congruent. So if you have a rectangle, the opposite sides are parallel and the opposite sides are the same length. Number 4, opposite angles are congruent. So the angles across from each other are the same size. Number 5, consecutive angles are 180. So meaning 2 angles right next to each other, like maybe this one on the bottom and this one on the bottom, they should add up to 180 in a rectangle. And then last but not least, the diagonals bisect each other. So what happens in a rectangle is when you draw in your diagonals, they're the same length and they bisect each other. They cut each other in half. So this and this are the same length, but since the diagonals are the same length, it actually turns out all 4 of those are the same length. Number 1, a rectangular garden gate is reinforced with diagonal braces to prevent it from sagging. JK is 12 feet. I'm going to put that on there. LN is 6.5 feet. So that would be here. And we are supposed to try to find KM. So KM is right here. It's a diagonal. It should be the same length as JL. And JL, we know one part is 6.5. And so what happens is all 4 of these parts have to be 6.5. So to find Km, we can just take 2 times 6.5, or we can take 6.5 plus 6.5. Either way, we should get 13 feet. Number 2, quadrilateral EFGH is a rectangle. The measure of angle FGE. So let's measure that, or let's mark that. There is angle FGE right there. That is 6x minus 5. So I'm actually going to put that in there. So here we go, 6x minus 5. And then the measure of angle HFE. So I'll do this in green. HFE down here is 4x minus 5. And we are supposed to find x. Okay, so here's how it works. This red triangle right in here, I've just outlined it in a darker red. That is an isosceles triangle. This and this are the same length. And because of that, this corner down here is also 6x minus 5. Because if it has two sides the same in that triangle, it's also going to have two angles the same. Now think about a rectangle. When you have a rectangle, the corners are 90. And so the 6x minus 5 plus the 4x minus 5, both of those together down here, should add up to 90. Because it's the corner. So then combine your like terms. We have 10x minus 10. Add 10. Then we get 10x equals 100. Divide by 10, x equals 10. And go back and look at your question. It says find x. We did that. Haha, it's one of our choices. So D is our answer. Number 3, Max is building a swimming pool in his backyard. He measures the length and width of the pool so that he knows opposite sides are parallel. And he also measures the diagonals of the pool to make sure they are congruent. How does he know for sure that the measures of each corner is 90 degrees? Okay, A, is it because sides were parallel that it had to be a rectangle? I don't think so, because just because sides are parallel doesn't mean it's a rectangle. It could be a parallelogram. So I think no for that one. How about part B? Since opposite sides are congruent, does it have to be a rectangle? Well, again, opposite sides can be congruent without it being a rectangle, so I don't think it's B either. But what about since the diagonals of the parallelogram were congruent? Does that mean it's a rectangle? Yes, it does. Think back to that thing about Marlin when we measured the two diagonals. If those are congruent, then your corners are square. So C is your answer. Number 4. If UZ is x plus 1 and ZS is 3x minus 15. Let's find those. UZ is here. ZS is here. This is a rectangle, by the way. I should write that on there. So if this is a rectangle, diagonals get bisected, so the x plus 1 should equal the 3x minus 15. Okay, now we want to solve this for x. So minus the x. Now we're going to add 15. Now we're going to divide by 2. And we get x equals 8. However, are we done? The answer is no. We have to find US. So take a look at US over here. It's all the way across the rectangle. But UZ and ZS are only halfway across. So in other words, it's going to take like 2 of the UZs to equal the US. It's going to take 2 of these red ones to equal US. So what I'm going to do is I'm going to say 2 of the x plus 1s will equal US. But we know x. So 8 plus 1 equals US. 8 plus 1 is 9. So that means 18 equals US. Number 5. If RZ is 3x plus 8 and ZS is 9x minus 28, find UZ. Okay, so here's RZ and here's ZS. So we're dealing with the red and green segments. This is a rectangle. It doesn't say it, it should. This is a rectangle, so what that means is all 4 of these are the same length. So to start out this problem, we would say, oh, the 3x plus 8 has to equal the 9x minus 28 because the red and the green segment are equal to each other. Minus your 3x. And then what would be next? Add 28. 36 equals 6x. Divide by 6. X equals 6. But we are not done. We need UZ. Now UZ, I'm going to outline it in blue right here. It should be the same length as RZ and ZS, so pick either one and plug it in. Like I'll just plug it in right here. So UZ is the same size as RZ. And so if I go 3 times 6 plus 8, if I just plug in the 6 to the RZ spot, I get 18 plus 8, which is 26. So UZ equals 26. Please pause the video and try number 6 on your own. Try to find R, S, and T. So I'll start with R. I see 4R here up on the top. Well, across from that, I see an 18. Now this is a parallelogram, so opposite sides are congruent. So the 4R should equal the 18. Divide by 4, R ends up being 4.5. Next, I'm going to look for the S. So I see 8S right here. It should be congruent to this segment over here because diagonals get bisected. So the 8S should equal 7S plus 3 minus 7S, S equals 3. And then last but not least, we're going to find T. This is probably the hardest one. T, I see a T up here on this angle. It's going to be congruent to this angle down here. Think about this side and this side being parallel, and then this cutting through. What we end up with is alternate interior angles. And so the 2T equals the 18-degree angle if the lines are parallel, and they are because it's a parallelogram. Divide by 2, T equals 9. One last question, and this is a review from section 4.1. So will you please pause the video and see if you can do this one? So I see we want to find the sum of the interior angles. We're going to have to do n minus 2 times 180. This is the formula for finding the sum of the interior angles. What do they all add up to? So if we have 16 gone, that means we have 16 sides. So we go 16 minus 2 times 180, which is really 14 times 180. And then you're probably going to have to type that into your calculator. When I typed it in, I got 2,520 degrees. So that's what all of the angles in a 16 gone would add up to. Well, that wraps up Unit 4, Lesson 3. So will you guys please try the practice? Unit 4, Practice 3. Have a great night.